Okay, so now let's start zooming into each of these tasks which constitute AI, and we'll start with problem solving, right? So what is involved in problem solving? This is best understood with the help of an example, and the classical example here is a game or a maze in this case, where you have, starting from somewhere in the maze or outside the maze, you want to reach to some location. This location could either be inside the maze, or you just want to go out of the maze from the other side, right? So this is a typical game that you're interested in building an AI agent that can play this game. Other instances of these games are something like a tic-tac-toe, where you have some moves and every time the agent could decide whether to place an X and O in certain location and keep going. And other such rules where the goal and the start position and the goal is well defined, and you want the agent to reach to a winning state or a victory state, right? So there are several such games, including this something like a version of a magic square, where you want to sort the numbers in a particular way or something like that, right? So now what happens in these goal-oriented games is that you can think of this, that at every point, the agent who is starting from the green dot here, right, you could think of it that at every point he can take a decision, right? So he started from here, green point, now he can decide to go to the left or the right. These are the only two options available to him. And then he continues doing this at every stage, at every turn, every corner, he can decide left or right and keep going ahead. And as he keeps doing this, at some point he might reach the goal state, right? And now for an agent, you could think of it that in this tree, it can enumerate all the possible paths, left, right, then again left, right, again all the branches, all the paths can be enlisted. Of course, I have not shown all the paths here, I have just done a representative diagram here, but you can imagine that there are multiple paths from the source to reach the target. Of course, in some mazes there might be only one path, in which case in these all multiple possibilities, many of which leading to dead ends, the goal is to find that path which leads to the winning state, right? So this is essentially a tree traversal problem, right? You need to find ways of efficiently traversing these trees. In some cases, instead of left, right, you might also have top and bottom, or more actions might be available. But I've taken a simple case here, which is left or right. Similarly, in the case of tic-tac-toe, you could imagine that I could build a tree where if I draw an X and then the opponent draws, suppose 5 squares have already been filled out of the 9 squares, and now I place an X in a particular square. So now for the opponent, there are 3 possible choices. He could place an O in 1 square, 2nd square, or 3rd square. So the 3 options which are available to him. And then again something could happen, right? And I could create the entire tree, and then my goal is to, in this tree, find that path which leads me to the victory state or the goal state, right? Here there is no data. I'm not really learning from large amounts of data here. I'm not really showing the agent multiple instances of the game or anything which has happened in the past. There's no modeling also. I'm not trying to say that there's some underlying data distribution, there are some relations here or anything of that sort. This is very different from what we saw in statistical modeling or algorithmic modeling. And the only thing needed here in such simple, well-defined games, where the rules of the game are very well known, is efficient search algorithms. And that's where in classical AI, you study A star, or its breadth first search or depth first search. These are some of the search algorithms that you study, right? So this part of AI, which is not at all data driven, it only relies on efficient algorithms for going from one state to another, does not intersect with the data science world. It's very different from the data science world, right? So that's what you do in problem solving. Now I'll come back and talk about the other tasks. Thank you.